Students, you are learning symmetry, rotation and reflection. See, children, you have learned about symmetry. Now reflection and rotation, you must have gone through the previous video and got the conception. Reflection, reflection, if you do it now for any object, think of the reflection, the axis through which it is reflecting, that is the mirror line. So exactly if you are putting an image in front of a mirror, the what will be it's behind the mirror, what will be its image? It will be just as much distance from the mirror, that much distance, the same image will be there, same shape and size. So that axis will be acting as the mirror line, or you can say it as the line of reflection. Okay, now then rotation, I have said to you, rotation, reflection, what is happened, whichever axis it is reflecting, that axis value remain unchanged, other axis, every point, when you do the coordinate system, every point has got two values. One is x coordinate value, and another is y coordinate value. So if it is reflecting on x axis, then the x axis value will remain unchanged, y axis value will change. If it is reflecting on y-axis, then y-axis value will remain unchanged and x-axis value will change. Rotation, it is different. I said the phenomena that is not in your syllabus. Of course, what is in your syllabus, it is very simple. Be with me in this video, you will learn. I will talk to you regarding the exercise of yours, that is exercise 8b and 8c. See children, I will tell you first of all what is the reflection of the following in the line of reflection. Line of reflection, I said you that through which an object is reflecting, or the mirror line, you can say. A line segment. A line segment, definitely, suppose it is a line segment. It is a line segment. Line segment has got 2 points, this point and this point. This point definitely from x-axis reflection. If it is x-axis is a mirror, think of x-axis is a mirror. Okay? X-axis is a mirror. Then that time, this will have 2 points, suppose PQ. P will be as far as from this point, exactly that point P dash will be, and Q dash also will be like this, as far from the line of reflection, so it will remain like that. So Q dash will be here, so it will become PQ is Q dash. Could understand this will could understand. So a line of line segment will have the same length line segment as reflection. A triangle, similarly, a triangle, suppose y-axis reflection you are going to do on a triangle. So y-axis, let it be like a mirror. Y-axis is a mirror, and then if you are reflecting a triangle, triangle will have 3 points. This is suppose A, B and C. See, this point will be as far from the y-axis, it will be somewhere like this. B point also will be somewhere like this, and C point will be as much this much distance. C point will be somewhere here, so it will become like this triangle. So it will be same size triangle, like this will be A, this will be B and this will be C. I hope you have understood it, the reflection, because it's a y-axis reflection. Had it been x-axis reflection, same way here it should come, and A will be as much for this, C will be here somewhere, and B will be there somewhere. You have got it? So it will be a triangle of same, it will be same congruent triangle like that. And a circle, similarly, a circle is reflecting. Suppose a circle is reflecting, it will be same circle, same radius circle will be reflecting. Could you understand? So line segment, you have to write down as line segment of equal length. A triangle of a congruent triangle, and circle, a circle of same radius. Now state the following, true or false. A circle has reflection symmetry about every line through the center. Yeah, through the center only a circle will be always, a circle will be always reflecting through the center only, and the same image will come. Now equilateral triangle has reflection symmetry. Reflection symmetry means on reflection it will be symmetrical. A circle will always be symmetrical on reflection. If you put a circle in front of a mirror, that will look other side of the mirror also, image also like a circle only. That is what equilateral triangle symmetry about the each line bisecting the angle of triangle. It's correct because each line bisecting the angle of equilateral triangle, that if these three are, each line, this line definitely has to be the bisector of this thing, means reflection line has to be the bisector of the triangle. So it's true statement. Now next is isosceles triangle. Isosceles triangle, will it be? Isosceles triangle has reflection symmetry about each of its altitude. It will not be. It's a false statement. Why? Isosceles triangle is different. Isosceles triangle is two sides equal altitude. For this base, this is the altitude. For this base, this is the altitude. If you reflect it, will it be symmetrical? No, it will not be symmetrical. So this is a false statement. A rectangle has got reflection symmetry about its diagonal. Rectangle will be having about the diagonal will be having the reflection symmetry. A rectangle will not be with the diagonal, it will be symmetrical. It's a false statement. Now question number 3 I have taken. Question number 3, this is a line of reflection, or the mirror line is given to you. These are mirror line. What is the line of reflection given? This is y-axis. This is y-axis. Any of the axis you can consider it as this x-axis line. So what will be the image after this axis? This axis, definitely this much length it will go. As much distance is that much. As much distance is this much. This, if you now connect with the mirror line, you will find the image after reflection. So this will be the image. Could you understand? Now this one also, this particular vertex has to be exactly opposite to it. So if you just draw a line with the axis, you will find this is the figure. This is a semicircle. See if it is the center of the semicircle. No, definitely it will be completing the semicircle to the other part. This will be the reflection. After reflection, it will go here. See this point, it will go exactly this point, and this point it will go up on the opposite of the axis. So this will be like that only, and this point also will be like that. Then if you connect these 2 points, you will find this is the figure. I hope you have understood. Now moving on to rotation, another exercise of the reflection rotation is left, that is rotation. Rotation is little different. See, especially it is talked about the rotational symmetry. On rotation, what position it will take? See, this object on rotation, this is point A, this is point B. If you give one, if these two ends are same, then if you give 180-degree rotation, it will be symmetrical. Point A goes to point B comes to point A. If you give 360-degree complete rotation and comes to the original position, it will be symmetrical. So it is having order 2. Like this, it is discussed to you. See, I will tell you, this is very simple only. See this one, which reflection rotational symmetry about point O. What will be? It has got, this is point O. Can you rotate and find the symmetrical position? Yes, if this part, if it is rotating, 90 degree, it will be, this comes to this position, this goes to this position, and this will go to that position if you are turning 90 degree. So it will be symmetrical. Now this one, if you are rotating 180 degree, that means this one comes to here, it will be symmetrical. And then if you are rotating this one to here, this one comes here, it will be symmetrical. And if you are rotating similarly this one and goes back to its original position, it will be symmetrical. So it will be symmetrical on the rotation of the axis on the point O, about the point O, in order 4. This will follow order 4. That is, they are 90 degree, then 180 degree, then 270 degree, and 360 degree. Is not it for this figure? For this figure, will it have rotational symmetry? Just see, about the point O, if you rotate it, it will not. It has to come completely up to 360 degree. That is not considered. That is, on rotation, it should, before 360 degree, it should come to a symmetrical position. So it will not have. So no rotational symmetry. No rotational symmetry. Could you understand for this figure? But this figure, you see if it is a point, if this part, this leaf goes to this position, it will be symmetrical. This leaf comes to this position, it will be symmetrical. That means this leaf goes to this position, it will be symmetrical. This leaf comes to this position, it will be symmetrical. And this leaf goes back to its original position, it will be symmetrical. So it will follow order 3. What are the order? See, 360 divided by 3, that is, and first of all, it will be 120 degree. For this figure, it will be 120 degree. Then how much will be 240 degree, and then 360 degree, isn't it? And in this case, it will become this order, this 4 order. You understand? That way, the rotational symmetry comes. I have taken question number 2. On point O, if you rotate, will it be having rotational symmetry, and what order it should follow? In this case, you see, I said to you, this blade goes to here, it will be symmetrical. This blade comes back to here, it will be symmetrical, and this blade goes back to the original position, it will be symmetrical. It will be order 3. What are the angles will be? It will be, first of all, 180 divided by 3. How will you find order? 360 is the total turn by, as many turn you are giving it. 3 turn you are giving it. So it will be order 3 only. So each angle, how will you find out? 360 divided by the number of turns. So 360, it will be how much? Angle will be 360 divided by 120 degree, 240 degree, and 360 degree. This order 3 will follow. In this case, if you rotate, yes, it will be having rotational symmetry, but it will have order 2 only. What? That will be 180 degree and 360 degree. Now in this case, you can have like this only 4 turns. So it will have order 4. What are the order will be? First 90 degree, then 180 degree, then 270 degree, then 360 degree. Is not it? If you rotate it. Okay. This one. This circle will have numerous rotational symmetry, but once the circle above this and the diameter is drawn to it, it will have order 2, because it has to, this end has to come here, there will be symmetrical, that is 180 degree, and this end has to come back to its original position, that is 360 degree. So order 2 in this case, what will be 180 degree and 360 degree. In this case, what order it will follow? It will follow again order 4. Order 4 it will follow. What are those order? 90 degree, 180 degree, 270 degree, and 360 degree. In this case, what order it will follow? It will again follow same order, that is order 4, that is 90 degree, 180 degree, 270 degree, and 360 degree. This way the rotational symmetry comes. Now, state true or false, that one. Equilateral triangle has a rotational symmetry, order 3 about the point of intersections of its altitudes. Yes, the altitude, equilateral triangle's altitude will be intersecting at a particular point, and if from through that point, if you rotate, no, it will be symmetrical. It is a true statement. A square has a rotational symmetry of order 4 about a vertex. No, it will not be about a vertex. It will be about the point of intersection, that will be. Okay. So it is false statement. Now a figure is given to you, just like I will draw the figure once. That figure. Similar like this figure is given to you. And it is asked to you that this figure is given to you, and it is asked to you has rotational symmetry, reflection symmetry about a line, but no rotational symmetry. It will be, of course, it will have a reflection symmetry. If it is the axis of symmetry, then here the point will be like this figure will come. No, reflection symmetry it will have, but rotational symmetry about a point, it will not have a rotational symmetry. A circle has rotational symmetry about the point, but no reflection symmetry about a line. That is a false statement because reflection symmetry also will be there. I hope things are very easy and you could understand rotation and reflection properly.